Good day, sir. Good day, everyone. I am Decadat Caparal, and we are the Group 2, and this is our output of our Prelim assignment week 2. So for the learning objectives or learning outcome, at the end of the lesson, the students will be able to explain the effects of wind, current, squat, shallow water on ship handling while maintaining safety of navigation. So effect of wind on ship handling. One of the natural factors about which every navigator should be very careful while steering a ship is the wind. Such vessels as container and ro-ro ships have a large freeboard and are thus more affected by winds. This exposed area of the ship is also known as windage area, as the effect of wind is more prominent over it.
When ship is at slow speeds during maneuvering or near to the coast, wind direction is easy to find, but this is not the case when out at high sea. The direction of the wind perceived when standing on deck is its relative direction. This is resultant of the true direction of the wind and the course steered by the ship. It is very important for the ship's navigator to steer the ship considering the wind effects so that the ship can be steered efficiently without any difficulty. Following are the techniques a navigator must master related to wind effects. The wind effect on the same ship will be different at different places, depending upon the draught condition of the ship. A wind the force of 3 to 4 on the Beaufort scale will have similar effect in light condition as with wind force of 7 to 8 when the ship is down to her max.
Good day everyone, I am Cadet Korea. So this is the effects of wind on the ship handling. So as we can see in the first picture, the channel 5 here, the effects of wind or the wind components. So as we can see, the ahead wind, which is the ship speed decreases, ship is drifting and turning moment acts on the ship. So as we can see, the wind force F here is not parallel to direction of VA. And also, in the third picture, as we can see, the effects of wind and the position of equilibrium ship with headway. So, the arrow here represents the real wind, and the wind action diminishes as soon as the vessel gets some speed. So the water pressure here influences the ship that all ships with headway will come into the wind, so between 1 or 2 points as compared with the ship's stop. So with the sternway also here, nearly all ships take an equilibrium position with stern wind, and loaded tankers take the wind in the stern quarters.
I'm Kadit Nanoko, and here's my presentation. So, effect of current on the ship handling. Ocean currents play a very important role in ensure the stability of the ship. The effect of current therefore must also be considered when handling ship in water. So, ang epekto ng agos sa makatuwid ay dapat ding isalang-alang kapag humawak ng mga barko sa tubig. So, effect of current are important especially when the ship is under the effect of onshore winds, near offshore platforms, while maneuvering in narrow channels and open seas, or in inland waters or harbors. When the ship is in harbors or inland waters and the current is at constant straight and direction, the ship handling becomes considerably easier. So, ang mga epekto ng agos ay mahalaga lalo lalo na kapag ang barko ay nasa ilalim ng epekto ng hangin sa baybayin. Malapit sa mga platform sa labas ng pangpang habang nagmamaniobra sa makipot na daluyan at bukas na dagat o sa panloob ng tubig o daungan. Kapag ang barko ay nasa mga daungan o panloob na tubig at ang agos ay nasa patuloy na lakas at direksyon, ang paghawak ng barko ay nagiging mas madali. So next is such direction exist only in comparatively narrow channels of the rivers. Second is, however, navigational officers should take into account different current streams that can exist over a small area within which the vessel has to maneuver. Next is the main difference between currents and winds in that current affect the ship and defined at predictable ways unlike the winds does. So sapagkat dapat isaalang-alang ng mga opisyal ng navigational ang iba't ibang kasalukuyang mga daloy ng maaaring umira sa isang maliit na lugar. So kung saan kailangang magmaniobra ang sasakyang pangdagat, ang pangunahing pagkakaiba sa pagitan ng mga alon at hangin ay ang mga alon ay nakakaepekto sa barko sa tiyak at mahulaan ng mga paraan hindi tulad ng tubig ay tulad ng hangin.
Effect of current on ship handling. So, effect of the current or position of pivot point. Current acts on underwater portion of ship. Next, when sailing with current, ground speed equals ground in water plus speed of current. Next, when sailing against current, ground speed equals speed water minus speed of current. So in the picture, that was the example or the position of pivot point or effect of the current. Next, when effect of current on maneuverability, turning in the current. A, with the current, the ship makes a wide swing. B, against the current, it makes a tight swing. Next, the effect of the current or working across a tide. Number 1, balance ship's speed through the water and tidal stream. Number 2, create sideway or lateral motion. Use rudder angle alone or with kick ahead. Current comes into opposite bow. Resultant of two vectors brings vessel towards the berth or crab-like. To stop drift, bring ships ahead into the tide.
Good day everyone, I am Deck Cadet Zaran Saracosa. So, let's proceed. So, the effect of current ship handling. So, even in open waters, when the ship is approaching a rig or a mooring buoy, due allowance should be made for the effect of the current for a safe maneuver. Current from ships ahead will reduce the ship's speed over ground, improve ship's response to the rudder, and also give more time to assess and correct developing situations. So, shallow water effects on ships or ship squat. When a ship proceeds through water, it pushes the water ahead. So, this volume of water down the sides and under the bottom of the ship. So, the streamlines of return flow are speeded up under the ship, causing a drop in the pressure and resulting in the ship dropping verticality in the water. So when the ship drops vertically, it trims both forward and aft. So overall, it decreases in the static under keel clearance, both forward and aft, and it is called ship's squat.
Good day everyone, my name is Cadet Istaka and I'll be talking about the shallow water effects on ship squat. If the ship moves forward at a greater speed in a shallow water, where the keel clearance is 1.0 to 1.5 meters, then there is a high chance of grounding at the bow or stern due to excessive squat. What are the factors that govern ship squat? The main factor on which the ship squat depends is the ship's speed. Squat varies approximately with the speed squared. The blockage factor S is the another factor to be considered while understanding the ship squat. The blockage factor is defined as the immersed cross-section of the ship's midship section, divided by the cross-section of water within the canal or river.
Good day, sir. Good day, classmate. I'm Cadet Estrada. Now, we are talking about what are the factors that give in ship squat. So, the blockage factor range from about 8.25 B for the supertanker to about 9.50 B for general cargo ship to about 11.25 ship breaks for container ships. The presence of another ship in the narrow river will also affect squat, so much so that squats can double in value as the ship pass or cross the other vessel. Next is on how to find out if a ship has entered shallow water. First is wave generation from the bottom of the ship increase, especially at the forward end of the ship. Second is ship becomes more than sluggish to maneuver. Then the last one is drought indicators or echo sounder will be indicated change the end of droughts.
Good day everyone, my name is Cadet Kenti Kamali and this topic is all about how to find a ship entered shallow water. Propeller RPM indicator show a decrease if a ship is open water condition without breathe restriction. Decrease maybe up to 15% service RPM water. So meaning if inyong vessel is mulabay o opensi niya kusog ang balod, meaning inyong increase yung RPM, so pinayan ninyo yung dagan sa inyong barko kay kusog kayo ang bawod niya. The next is there will be drop in ship speed if ship is open water condition. This may be increased to ship confluent channels canal to 75%. So meaning kusog ni siya drop na yung speed if the ship is open water condition. Decrease may be up to 35%. So hinay siya up to 35%. Hinay ang speed sa yung barko. So next is the ship may start vibrate suddenly. This is because of water effect causing natural hull frequency become resonant, another frequency associated with the vessel. Meaning kung imong ship is start to vibrate, it is because agi na saya ang water effect tungod sa hull if ang vessel mulihok o motingog siya. So next is any rolling pitching and having motion will be reduced. Ship moves from deep water, shallow water condition. This is because cushioning. So meaning ang tuyok sa tubig or ang iyang pag-receive sa tubig hinay padong sa shallow sa deep water to shallow water. So agi sa iyang cushioning. So meaning na sa cushioning is softening the effect to the impact. So iyang gipahinay or gipasok ang impact.
Good day everyone, I am Cadet Hamisula Ogjelken and this is my assigned topic. So how to find out if a ship has entered shallow water? So number 8, the appearance of mud clouds will be visible in the water around the ship's hull when the ship is passing over a raised shelf or a submerged wreck. So number 9, turning circle diameter or TCD increases. TCD in shallow water could increase to 100%. And the number 10 and 11 is stopping distances and stopping times increase as compared to when a vessel is in deep waters. Number 11, effectiveness of the rudder helm decreases.